Hello and welcome to how a nuclear reactor works.
So this is going to be the basic science on how a nuclear reactor works. Just so you know, this paper looks really weird because I just kind of got it wet and I had to have it dry out, in case you're wondering why it looks like that. Okay, so this is going to be what we're going to be talking about is the basic science behind a nuclear reactor, how it works, and then we're going to be checking out the worst nuclear disasters in history if you want to stick around for that. And then we're going to be talking about the Chernobyl accident to see how that happened. And don't worry, this probably won't be a very long video. I reckon only about 6 minutes in case you're wondering. And it's not that many facts. We're breaking it down pretty simply for people who just want to learn as a regular, simple way to just start getting into how a nuclear reactor works. So we're going to start out. So first, a nuclear reactor uses intense heat to create steam that powers a turbine. The turbine is not in this picture, sadly, but as you can see right here, that is where the heat exchanger happens and it creates steam. See where that arrow is up there? That steam goes down this tube right there. That tube then leads to a turbine, which creates more power. You might be wondering, why not just use coal? Because we're running low on fossil fuels, and this creates more steam faster than burning wood and coal, and it creates power faster than making it easier to have, well, not as easy to have a power shortage in your house. 3 crucial components to a nuclear reactor is the fuel element, the moderator, and the control rods. So a moderator is what cools the reactor or slows down the reaction that's happening within. So the reaction, which is the uranium neutrons shooting around, and occasionally the uranium neutrons will hit one another, bouncing off each other, creating energy, and then hitting more uranium atoms, and then bouncing off of that and creating energy because they're bouncing so fast. What the moderator does is slow that down so it doesn't get too hot and melt. And the control rods, which are seen here, slow that too, but are usually out of that so they can speed it up and slow it down depending on the power needs. 3, thin fuel rods go in the reactor core. Those fuel rods help power the reactor core so more fission can keep happening if the reactor core is shut down. A moderator is for slowing down the energy neutrons, and the reactor, which I told you about earlier, that the moderator slows down the uranium atoms bouncing off each other, creating power. Ordinary water or heavy water is used for the moderator. Heavy water is water with more hydrogen, and more hydrogen would slow them down regularly than regular water, but it really doesn't matter which one you use. Control rods slow down the energy process, which I already explained before, and I'm going to explain it again. It just slows down the neutrons, kind of like how the moderator does. And the control rods are made of boron or cadmium, I believe. I'm not the best at that. But boron and cadmium slow down radioactivity, and those are in the control rods that slow down radioactivity and the moderator. So now we're going to move on to this quick thing on different dates of what's the worst nuclear explosion and the best. So first we gotta learn about a couple things. First, fission is in the cooling water, and fission is called when you split something apart. Fusion is when you fuse something together, right? When you put something together. Fission is shooting stuff apart. So these are fission reactors, which means it bounces stuff off of each other, splitting the atoms in half. So that's called fission. Okay, so just a fun fact that uranium's half-life is 4.47 billion years. Okay, now we're going to get to these. So the worst nuclear reactor in history is Chernobyl, followed by Fukushima and 3 Mile Island. I don't know, I just wanted to get those facts out. Now we're going to move on to the Chernobyl nuclear disaster. Chernobyl was the worst nuclear disaster in history, in case you did not know. It released so much radiation that so many people died from cancer and other things. I'll dedicate an entire episode to Chernobyl probably later today or tomorrow, coming soon, so watch out for that video. To stop radiation, use iodine pills. This stops you from absorbing radiation. So for any reason, if a nuclear reactor head explodes or melts down and you have to evacuate, I recommend taking iodine pills if you're near that area so you stop absorbing radiation and you have a less chance of getting cancer. Or you could use that if you live by a nuclear reactor because it still releases steam and toxic gases into the atmosphere that can still have the possibility of giving you cancer. So I recommend taking iodine pills if you are near a nuclear reactor at all times. Chernobyl control rods are made of boron, which reduces radioactivity, but the tips are made of graphite, which accelerates radioactivity, causing the reactor to explode. So you might be wondering, how does this work? Stick around for episode 2 of this so you can figure out how Chernobyl exploded. That will probably be made tomorrow, so watch out for that tomorrow.